Hey everyone, Malleo here. Back in 2013, I made a tutorial that covered the basics for setting up Dolphin Emulator and how to begin making tasks on your own. This video is highly outdated and there are a couple things I didn't cover, especially how to actually manage recording files, since I had been focusing on Mario Kart Wii tasks, which don't actually require you to make a recording file to store your tasks inputs. In addition, since then, Dragonbane and Swearjong have developed a custom version of the Dolphin Emulator, which allows you to use Lua scripts to automate portions of your tasks, as well as create an on-screen info display to monitor game addresses. And I definitely think it's important to include information about using this emulator version. So today, I will cover how to create your own tasks from a beginner's perspective, so that anyone watching this would be able to create their own tasks. If you've ever shown interest in making a task of your own, then please be sure to stick around to learn. I assure you the process in its simplest form is not at all complex, so don't be afraid that it's going to be difficult. If you'd like to skip to a specific point in the video, here are timecodes to find the information you need. So with that, here's my tutorial on how to create Gamecube and Wii tool-assisted speedruns using the Dolphin Lua Core emulator. Before you do anything else, you need to obtain a digital copy of the game you'd like to create tasks for. While I can't suggest ways for you to obtain the game illegally, there are ways if you decide to search around. To assure legality, you can use a homebrew app on your Wii called CleanRip. If you've purchased the game disc, then you're legally allowed to create a digital backup of the game, though be sure not to distribute this backup as that goes against copyright law. Before I go on, I need to mention that this specific version of the emulator is only available for 64-bit Windows operating system. To download a version for 32-bit Windows, or macOS, navigate to dolphin-emu.org, go to Downloads, and find the 5.0 stable release build near the bottom of the page, and find your relevant OS download. As a result, though, you will not be able to utilize Lua scripts in your tasks, which isn't a huge deal in the grand scheme of things. If you have 64-bit Windows and want to use Lua scripts for your tasks, you'll want to go to Swearjong's GitHub repository for the custom Dolphin build. Click the Releases button, and download dolphin.zip under the most recent build version. Once downloaded, use a program such as WinRAR to open up the zip folder. From here, extract all the files to a new folder of your choosing. Keep in mind that save states are several megabytes in size. If you have multiple drives on your computer, such as a hard drive disk and a solid-state drive, then it's important to place Dolphin in a drive which offers the fastest read and write speeds and one which has a decent amount of storage space. If you choose a drive with slow read-write speeds, then the process of saving and loading states will become noticeably slower than is best. In the Dolphin folder, create a blank text file called portable.txt. You don't need to write anything in it. This file will cause all dependent files to be stored in this folder. Normally, Dolphin settings and save states and such are stored in your Documents folder. However, if you have multiple different versions of Dolphin, then changing settings in one version will therefore affect the settings in all other versions. To avoid messing with other versions of Dolphin, and in order to better access save states and such, it's best just to create this portable.txt file. From here, simply open Dolphin and we can get started modifying some important settings. At its base, a tool-assisted speedrun is simply a file of inputs being played back. After creating this file, it's important that the inputs being played back synchronize correctly. What I mean by that is that if you press the A button and held the analog stick to the left on a certain frame, then it's important that those specific inputs are processed on the same frame as when you originally pressed them when recording to the input file. I'll touch on the importance of synchronization later in the video, but for now, in order to preserve synchronization, we need to tweak a few settings. First, navigate to Options and then click Configure. We need to uncheck both Enable Dual Core Speedup and Enable Idle Skipping Speedup. These settings can produce a non-deterministic result, meaning that the game may not be played back the exact same way on every playback. Next, click on the Audio tab. In previous versions of Dolphin, there have been synchronization issues when using DSP-HLE emulation, which is basically the highest quality audio option. However, I believe that synchronization problems with audio have since been fixed and it's safe to use HLE. If you experience synchronization issues later on, or if you'd like to play it safe, then it's best to set this to DSP LLE Recompiler. Audio quality may not be as optimal, but that's a small sacrifice to make in order to make sure your tasks actually play back correctly. Next, go to Options and Controller Settings. Depending on what type of game you're playing, you may not need a Gamecube controller or a Wiimote to be active. Simply click the drop-down box and select None if that's the case. Some games may experience graphical problems as the result of inaccurate emulation. To see if your specific game needs any settings tweaked in order to run properly, go to dolphin-emu.org, click on the wiki, and search for your game title. Note that some emulation issues may have been fixed on newer versions of Dolphin, so it's important that you look for fixes to issues that have not been fixed in the 5.0 stable release. To display a list of your games, you'll next want to double-click here and select the folder containing your game ROMs. Next, click Options and click on Hotkey Settings. On this screen, you can set various different hotkeys to perform different tasks. Most importantly, you'll want to set a frame advance hotkey. This hotkey, when pressed, will cause the game to advance one frame at a time, which is the smallest time unit that a game runs at. This will effectively allow you to play the game in slow motion in order to optimize your tasks as best as possible. Additionally, I'd recommend setting a read-only mode hotkey. Toggling read-only mode will effectively allow you to quickly rewind and play back inputs that you've just pressed, as well as regain control at any point when playing back your inputs. Finally, I'd also suggest setting a toggle pause hotkey to allow you to easily switch between a pause and full speed. Overall, you want to arrange these hotkeys in a way that you can save and load states and frame advance without having to reach all the way across your keyboard. Design your hotkeys to your liking while making sure each hotkey is quickly accessible. One last topic I'd like to cover is the most optimal way to send controller inputs to the game, task input. Task input is essentially a virtualized controller. In this view, you can set precise angles for the analog stick and C-stick. Additionally, you can left-click any of the checkboxes to enable a button press. Also, you can right-click any of these checkboxes in order to have the input be pressed every other frame. This will be especially handy as I demonstrate how to mash through text boxes as fast as possible for Paper Mario: The Thousand-Year Door. With that, we're ready to get started. Left-click on a game of your choosing, then go to Movie and click Start Recording. You'll want to immediately press the frame advance hotkey to freeze the game. From here, you can continuously press or hold down the frame advance hotkey to advance through the beginning of the game's boot up screen. I'll be using Paper Mario: The Thousand-Year Door to demonstrate the process of working on a tool-assisted speedrun. For the beginning menu, I know that a cutscene will start playing after the Dolby image, thus I need to stop frame advancing, save a state, and attempt to find the first possible frame that I can press A to advance to the title screen. By default, the save state hotkeys are as follows. To load a state from one of 8 reserved slots, you can press any key between the F1 button and F8 buttons on your keyboard. To save a state, just hold down Shift and press a key between F1 and F8. F1 represents the first reserved slot, F2 represents the second slot, and so on. So by pressing Shift and F1, I've saved a state in the first slot. I tried to press A on the frame that I saved on, but I noticed that the screen does not fade to white, so I pressed it too early. So I load the state by pressing F1, and advance one frame further, and I resave the state. Now I try to press A on this frame, and it's still too early. I repeat this process until I find the frame that works, and I reach the title screen. Similarly, I need to find the first possible frame to press start at the title screen. I can repeat the same process of testing one frame, reloading the state, advancing one frame, and resaving the state, and so on. Once a text box appears, I know that the fastest method of skipping through text boxes is alternating A and B every frame, so on the first frame I can right-click the A button, advance one frame, and then right-click on the B button. Thus, A and B will now alternate every frame until I uncheck the boxes. Once I gain control of Mario, it's time to talk about game addresses. In any task, it can be highly important to be able to look at addresses in the game. For example, in TTYD, it's important that I monitor speed and position values. If you're attempting to make a task for a game whose source code isn't well explored, then the process of just finding addresses for certain memory values can be quite easy. Go to Aldolaro's GitHub repository to find the Dolphin memory engine. go to the Releases tab, and download the windows.zip folder for the most recent build version. Extract the files to a folder of your choosing, and boot up the memory engine. It should automatically say that it's hooked to Dolphin if Dolphin's already open. If not, click the hook button to retry. From here, we can search for values of addresses in the game's code. So let's say I want to try to find Mario's x-axis position. First, positions in most games are a floating point number, so let's change the type to float. Well, when we get control, we don't exactly know his position, so let's just set it to unknown initial value and click first scan. This will spit out a ridiculous number of results, but we can use additional searches to narrow the results down. Let's have Mario walk to the left a tiny bit. Since Mario moved to the left, his x-axis position should have decreased, so we can select decreased in the second dropdown and hit next scan to return only the addresses which have decreased in value since the previous search. If we move him to the right afterwards, then we can search for an increased value. If we move him up or down, then we know that his x-axis position has not changed, so we can just scan for unchanged values. We should be left with a few different addresses. We can take all the addresses and add them to the watch list below by clicking Add All. From there, we can double-click on an address's value and attempt to change it. By changing this first address, we find that Mario's position doesn't actually change, so we can delete it from the list. Keep doing this until you find the address that's responsible for storing his position. Thus, we've now found his x-axis position and can do the same for his other directional positions, as well as his speed value. Next, let's cover the process of displaying these values on Dolphin's screen. Thanks to this Dolphin version, we can use a scripting language called Lua to display values on screen. Start by opening a blank file in Notepad or a similar program. First, we need to define a blank function called onScriptStart. You can modify this function to initialize script variables or perform certain operations whenever the script is first started. Even though we don't really need this function for anything, Dolphin will throw an error if we don't include it. Similarly, we should also include the onScriptCancel function to prevent a warning message when the script stops running. Next, let's define the onScriptUpdate function. This function is defined to run every time Dolphin polls for controller inputs. So anything we write in this function will be run every frame, though there is one issue that we'll have to deal with later. For now, let's define a string variable called text and just set it to blank for now. Let's display Mario's x position. We can start by appending the string, then writing string.format with an opening parenthesis. Then in quotes we can write x position %10.6f. The %10.6f is a formatting parameter for floating point numbers, and it means that we'll just display a maximum of 10 digits before the period and 6 digits of decimal precision. After this, let's add a comma, and then call the readValueFloat function. This way, the returned value of readValueFloat will be represented in the string as a floating point number. In this example, we want to pass in the hexadecimal address of Mario's x position, which is 0x80B074AC. When Dolphin processes this address, it actually just chops off the first byte of the address, so you can either leave the address like this, or you could just rewrite it as 0xB074AC. Either way is fine. Let's close out our parentheses. Lastly, to actually display text on screen, we need to call the setScreenText function and pass in the string that we want to display, which in this case is our text variable. Let's save it. If you want the script to be run automatically every time you boot up a game in Dolphin, then we can add an underscore to the beginning. If not, that's fine too. Save the script by going to your Dolphin folder and go to sys, then scripts, and save to this location. Now let's go back to Dolphin. If you decided to add an underscore to the script name so that it's run every time a game is open, and Dolphin is currently open, then you'll want to save state, close out of the game, and reopen the game, and load the save state so you can get back to where you just were. If you chose not to add the underscore, we need to load the script manually. Navigate to Tools, and click Execute Script, and select the script you just saved from the dropdown. By default, there are a few example scripts primarily for Mario Kart Wii. If you feel that you won't need these, feel free to delete them in the sys scripts folder. After selecting your script, press Start Script to start it up. On the next frame update, you should see text displayed on screen, and if you followed everything correctly, it should now correctly display the address you chose. Another thing to keep in mind too, if you paid close attention earlier, I said that a script with an underscore at the start of its name will execute automatically every time you boot up a game. If you would like the script to only run when a specific game is opened, then we can add an if statement to prevent the script from running for other games. We want to check the game ID and see if it matches the game that you want the script to run for. We can simply get the string for the game ID by calling readValueString and passing in an address of 0 followed by a 6, meaning we want to get a string of length 6. Next, we want to get the game ID for the game we want the script to run for. Try Googling for the game you want followed by game ID. You should find a 6-character string that represents the game you want. Note that if the last letter in the string is an E, then it represents the North American release, a P represents the European release, and a J represents the Japanese release. So let's write that string into our if statement and compare it to the game ID we extract from Dolphin. We want to cancel the script if the IDs do not match, so we'll use the not equal to comparator and then call cancel script. And with that, we've successfully implemented a very basic script. One thing I would highly recommend doing is implementing a core file. This file can basically act as a hub for obtaining all relevant addresses. This way, you can have readily accessible addresses without having to rewrite them in each of your separate scripts. We start by declaring a local empty Lua table called core. Then, we can define a function for obtaining Mario's position coordinates. We start by declaring a local function called getMarioPos. It's recommended to declare these functions as local, as it can tremendously speed up script execution. Otherwise, it could lead to performance problems depending on how many functions you write. Instead of having 3 separate functions for each of Mario's position axes, we can just have one function and return a table of all the axes' positions. So for this function, let's return the following table. X is equal to readValueFloat 0xb074ac, Y is equal to readValueFloat 0xb074b0, and Z is equal to readValueFloat 0xb074b4. Lastly, in order to add this function to the table that will be sent to any scripts that want to use this function, we need to add core.getMarioPos equals getMarioPos. Make sure that the name after the equal sign is the same as the function name. Once you're done implementing as many functions as you want, be sure to include the return core statement at the bottom. Save this file in the main Dolphin directory. Now, let's go back to the display script. At the top, let's write local core equals require, and then in quotes, whatever you name the core file. Now if we want to get Mario's X position and display it, instead of having to write out the address every time, we can now just call core.getMarioPos and add the opening and closing parentheses, and add a .x to get just the X position. Let's save and rerun the script, and it should work perfect. Now I'll be writing a script to automate controller inputs. Sadly, this is only implemented for the Gamecube controller inputs. As such, Wii games that require a Wii remote to be used cannot benefit from automated inputs. This is currently being worked on, so there's a chance that it's now possible, so be sure to check out Swearjong's repository for updates. Let's write a simple script that'll press up for 2 frames, left for 13 frames, and jump on the 14th frame. Now, before we get started, it's important that I point out one flaw with this Lua build. Earlier, I mentioned that the onScript update function is called every frame. More importantly, it's called every time Dolphin polls for controller inputs. However, in this Dolphin version, the emulator actually polls for inputs multiple times per frame at an inconsistent amount. Thus, it's highly important that you always implement a way to track the frame count in order to assure that buttons are being pressed on the frame that they should be. Let's begin by writing the onScriptStart function. When the script starts, we want to declare a variable called startFrame, and let's obtain the current frame by calling getFrameCount. Next, let's declare onScriptUpdate. Here, we want to perform the logic to determine what buttons to press on a given frame. In order to determine which frame in the sequence we're on, let's add another variable called currentFrame, and we'll set it equal to the value obtained by calling getFrameCount. Next, we want another variable to track what frame in the sequence we're at. So let's set frame difference equal to current frame minus start frame. So let's add a bunch of if statements. The first case of the sequence is where we want to press up for 2 frames. So let's say if frame difference is less than 2, since we want to press up when the frame difference is 0 and when it's 1, then we want to call set main stick Y 255. This will set the analog stick to an up input, whereas a value of 0 would set it directly down. If this isn't the case, then we want to say else if frame difference is less than 15, then we want to call set main stick X 0. This will register as a left input. Lastly, else press button A. The documentation for this build incorrectly states that the press button function will cause the button to be held down continuously until you call the release button function. However, as a result of a bug, the button will be released on the next input pull. Again, because of this, it's highly important that you use the frame count when performing logic, as otherwise some inputs will not correctly be registered. Let's save this and run it. As intended, it correctly causes Mario to walk up for 2 frames, walk left for 13, and jump. As you can imagine, as you learn Lua, you can begin to write more and more complex scripts to accomplish so many things. For example, in TTYD, we were able to use it to index RNG values by incorporating several different functions, and I also used Lua to brute force RNG manipulation for a cutscene in Chapter 1 whose length is random. Let's go back to the less technical side of tasking so I can explain some more basics. Let's say you got to a certain point in your task, and you want to replay what you have from a certain point without having to close out a Dolphin. Wherever you're at, you can enable read-only mode by either using a set hotkey or navigating to Movie Read-Only Mode, load an earlier save state, and watch the playback of all your previous inputs. While in read-only mode, be careful that you don't load any save states that did not occur from the start of your recording up until the end of it. Doing so may result in desynchronizations, as you're essentially loading a save state that occurred in a different timeline apart from the playback's timeline. To exit out of read-only mode, toggle read-only mode either by navigating to the movie menu again or by pressing your hotkey. From there, load a save state of your choosing, and you should see text in the top left corner of the game window that says recording. If you don't, then you are no longer recording inputs, most likely as a result of having finished playback in read-only mode. If you do see recording in the top left, then you've successfully went from read-only to recording mode. If you don't see recording in the top left, then make sure you disabled read-only mode and load a save state that was made in the middle of either recording mode or playback mode, and you should switch back to recording mode. If you'd like to end the recording at any point, you can either exit out of the game window or go to Movie and click Export Recording. Doing either of these will prompt you to save the recording file to your computer. You can then play back these tasks easily by left-clicking on the game in the game list and going to Movie, Play Input Recording. To make the process of playing back segments of longer tasks a lot easier, I recommend saving a save state to a file every so often. This is different from using one of the reserved slots, as those can be overwritten. Instead, you can navigate to Emulation, Save State, and click Save State. This will allow you to save a state and its associated recording file to a location of your choice. This way, when you play back a long task, you can begin playback from the start of the game, then go to Emulation, Load State, and click Load State in order to fast forward playback starting from that stored save state. Let's say you completed a section of the game, but found and went back for improvements earlier in the game. You may wonder if the inputs in the furthest section may be lost since you went back to an earlier point in the game. However, as long as randomized enemy positions or similar random events don't prevent your previous inputs from still working, you can copy and paste your inputs for the furthest section. To start, you need some kind of easily identifiable change in button presses to make it easier to see where the section starts. Let's say that I reached the end of this room and made it down to the pipe, but I ended up going back to a previous room to fix something. So we have 2 recordings, one which makes it past this room, and one which implements earlier improvements and only enters the room. We'll need to find a program that can view the data of the input recording files. I personally recommend HXD, as it's pretty simple and easy to use, but you can instead find a similar program. In HXD, we need to open both the recording that made it past the room, and the one that only enters it. In the recording that made it past the room, we want to go to the end and try to determine the first frame that we gain control in the room. I keep scrolling upwards until I notice a long period of blank inputs, which means that the room is loading and I haven't gained control yet. Luckily, it's fastest to use a glitch involving jumping in this game, so I can just look for the first A press to identify when I gain control of Mario. A is represented in the input data as 02 in the first and 9th columns, so from this point until the end of the recording, let's copy it. Then in the other recording, I similarly want to identify the first frame that I gain control of Mario and jump. Once I find it, I can highlight the first frame until the end of the recording, and then paste the inputs from the other input file. This will overwrite what I have highlighted, but also write the rest of the inputs to the file. Lastly, in its header, the input file tracks the frame count of the movie. Even though we have inputs up to the end of the room, the recording playback will end early because the header states that the input file ends before the end of the room. So let's go back to the longer input recording and just copy the header. This isn't the cleanest way to do it, as it would be better to just adjust the frame count trackers in the header, but I find that this is the fastest and easiest way to do it. So highlight and copy the header, then highlight the new file's header and paste to overwrite it. As long as the frame count of the input file that completed the room normally is sufficiently large enough, then the newly edited input file should play back normally. Let's test this out, and you can see that it correctly gets to the end of the room. Again, to regain control once the room ends, be sure to disable read-only mode, save a state, and load it. Assure that the top left of the screen now says recording. Lastly, I'd like to cover the process of actually recording a video for your tasks. If you'd like to increase the quality of your video, first go to Options, Graphics, and click the Enhancements tab. From there, you'll want to set the internal resolution to something higher than native. If you want 1080p quality, then set it to 3 times native. Anti-aliasing is used to smooth out edges, and anisotropic filtering is used to eliminate blurs for textures viewed at certain camera angles. You can enable these if you want to, but I choose not to. Next, close out and go to Movie and click on Dump Frames and Dump Audio. Next time you start a game, it'll start recording an audio and video file to the user/dump/frames and user/dump/audio folders within your main Dolphin directory. Note that the width and height of the output video scales with your Dolphin window size, so you need to enlarge your window to raise the width and height. Alternatively, you can use a program such as Infinite Screen to stretch the window past the normal limit of your monitor. So to record a video for a task, go to Movie, play Input Recording, and it'll start recording. Once it's done, you can simply close the game window. This version of Dolphin uses the Xvid codec, though you can change it to the FFV1 codec by going to Options, Graphics Settings, Advanced, and checking the FFV1 checkbox. However, both of these formats give me issues with the editing software I use. If you find that to be the case, then it may be useful to use a program like VirtualDub to re-encode it using a different codec, or if you're really fancy, I recommend using FFmpeg from command line. Well, that was a lot of information to cover, and I hope that you all understood it. If you aren't too familiar with programming, I would highly suggest trying to get started by writing your own scripts for tasks. Lua isn't the best first language to learn, but it'll definitely teach you some important fundamentals. Hopefully, you all now know the process of setting up Dolphin, setting up the Dolphin memory engine, finding and obtaining relevant game addresses, displaying these addresses on screen, hex editing inputs, and completing and outputting video for your very own tool-assisted speedrun. The process of making tasks is very difficult when first starting out, but I assure you after spending enough time working on making tasks, you can become a pro in no time. I think you'll be glad you did it. With that, happy tasking, and thanks for watching.